Alrighty, sorry about my notes today. I wasn't able to record all day through technical difficulties. So I'm just gonna kind of hit the high points as far as inverses go. Basically, an inverse is just we're going to switch x and y. That's the main thing we're looking for as far as that. When we're solving equations and we're trying to look for the inverse, we actually want to switch x and y, and then we'll actually solve for that new y. So that's the biggest thing. That's like, if I could tell you one thing as far as inverses go, that's pretty much it. There are a few things that we'll go deeper into later about what inverses can do as far as undoing each other, blah, blah, blah. But for right now, all you got to know is that switch x and y and solve. There's a couple of parent functions that are inverses of each other. So like the first one is quadratic. The inverse for quadratic is square root. And then the other one, the inverse for cubic, is probably, as you guessed it, cube root. That's pretty much it. There's a couple of things that I mentioned in class today. One is the one-to-one, and that basically means that there is one x paired up with one y, and that's specific. So for example, the quadratic parent function y equals x squared would not be one-to-one because at this point and at this point they have the same y value. It's the same y value. Even though it's different x values, it's still the same y values. So that would not be one-to-one. There's something called the horizontal line test, which is very similar to the vertical line test. This tells if something is one-to-one, so I'm just going to write here determines right there. And so that determines it. So if you draw a horizontal line right there, it hits it twice, so therefore it's not one-to-one. And this also determines if the inverse is a function or not. And so what we're doing there is that we're determining if I were to actually find the inverse, which I'll draw on here, so the inverse would look something like this. Is that a function? Well, instead of doing all that stuff, I can just, once again, do the horizontal line test and tell if this is going to be a function or not. By this way and this way, obviously, vertical line test, it hits it 2 points. It's not a function. But that's just a way to tell without doing all the work. I'm going to do a couple examples, and then I'll be done. Excuse me. The first example is going to be y equals the square root of 3x plus 6. You have to do three different things on your homework, so I'm going to go ahead and do those three things. The first one is to solve for y, or solve for the inverse. So I'm going to do that by first switching x and y. Then I'm going to square both sides, which gets rid of the square root. My bad. So then I have x squared equals 3y plus 6. Next step after that is I'm going to move 6 over. So x squared minus 6 equals 3y. Divide both sides by 3. And so the inverse is going to be that 1/3. I'm putting that 1/3 out in front as a coefficient and then dividing negative 6 by 3, which is negative 2. The second thing you have to do on your homework tonight is to graph it. So if I were to graph the parent function, or not the parent function, the original function, I first need to factor out a 3, and that's just a technical thing that an experienced mathematician would know that I need to factor out a 3. And so basically, this is the gist of what my picture looks like. It moves over to left 2. And so remember that my two graphs are symmetrical across that line, y equals x. So my other one should look something like this, and it does. It looks like that, looks like that. If I were to do this in a different color, that'd probably be easier to tell. So give me a sec, my bad. So that would go there and then go there. So we can see that this line right here, this part, and then this one are symmetrical. Kind of hard for you to tell, but that's kind of what that is. And then the last thing on our homework is list the domain for, the domain for both of them. So the domain for my black line is everything bigger than or equal to negative 2. My domain for my yellow one is all real numbers. The other example is a little easier because of lines. The equation is y equals negative 2x plus 5. So switching x and y first. Moving 5 over. Divide by negative 2. And so y is going to be negative 1/2 x plus 5/2. So when I go to graph that, I'm first going to graph my original here. So I'm starting up at 5. I'm going down to over 1. So my graph kind of looks something like that. Getting the gist of it. You can obviously be better at home with graphing that. I'm just doing it quickly to the sake of time. My other one's at 5/2, so that's 2.5, and I'm going down 1 and over 2. Down 1 over 2. So my other graph is going to look kind of like that. And if my graph is drawn to scale, we would see that pretty close, that my lines are reflected across the line y equals x. The last thing is our domain for both of those is going to be all real numbers. If you want to write that from negative infinity to positive infinity, that's fine. That's pretty much the gist of inverses. Biggest thing, switch x and y and solve for y. And then if you want to graph those, it reflects across the line y equals x. Have a good day. See y'all tomorrow.